Welcome to Unacademy. Let us crack GATE and ESE. This is Umamaheshwar Rao. This batch is Super Talent Batch for Engineering Sciences XE. Unacademy presents free classes curated by India's top educator. Myself, Umamaheshwar Rao. Scan QR code to watch now. Link in description below. Unacademy Unlock 20% off on GATE and ESE, ME and Chemical Engineering subscriptions. Last day for offer. Use code KUR75. Unacademy Unlock 20% off on Unacademy Light Distance Learning Program subscribers. Last day for offer. Final call to buy GATE printed notes till August 31st. Available for existing plus and iconic subscribers in mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and information technology. Last day to avail 20% off. Use code KUR75. Unacademy Light Distance Learning Program. Test series and printed notes for GATE and ESE, mechanical and chemical engineering, 16 printed books with over 4,800 pages curated by top educators, 60 plus topic and subject wise full length mock tests, chapter wise practice questions and solved examples, available from 10,942 rupees. Use code KUR75 to get 10% off. Unacademy GATE and ESE present Combat scholarship test to ace your GATE preparation. 20 questions in 60 minutes. Test will be conducted on 28th August at 11 AM. GATE 2023 is less than 6 months away. Begin your preparation with Unacademy iconic subscriptions. 3,104 rupees per month. Exclusive test series, printed notes, 1:1 live mentorship program, customized doubt solving sessions. Subscribe now. Unacademy is announcing Ummeed batch for GATE 2023. Batch commences from September 1st in mechanical engineering. GATE 2023 is less than 6 months away. Unacademy is announcing Vision batch for GATE 2024 and ESE 2024. Batch commences from August 25th. Unacademy GATE and ESE iconic subscribers, we have something new for you. Exclusive iconic test series. 5 tests are bundled per branch. More than 140 questions per branch. Questions are prepared by the top educators, peer-to-peer, score comparison, detailed result report for live test takers, new tests every week. Enroll now. First, I would like to explain how to calculate residues of a complex function at simple pole, pole of some order. So what is the residue? In Laurent series, in Laurent series expansion of f of z, the coefficient of 1 by z minus z naught The coefficient of 1 by z minus z naught is called, in Lorentz series expansion of f of z, the coefficient of 1 by z minus z naught is called residue of f of z at z equal to z naught. Residue of f of z at z equal to z naught. For example, f of z is z minus 1 by z minus 3 into z minus 5. If you write a by z minus 3, b by z minus 5, to get numerator of z minus 3, put z equal to 3 in the other term. 3 minus 1 by 3 minus 5. 3 minus 1 is 2, 3 minus 5 is minus 2. 3 minus 1 is 2, 3 minus 5 is minus 2. So 2 by minus 2, minus 1 plus, put z equal to 5. 5 minus 1 by 5 minus 3. 5 minus 1 is 4, 5 minus 3 is 2. 4 by 2 is 2. Now, the coefficient of 1 by z minus 3 is minus 1. Residue of f of z at z equal to 3 is minus 1. Residue of f of z at z equal to 5 is 2. The coefficient of 1 by z minus 3 is residue of f of z at z equal to 3. The coefficient of 1 by z minus 5 is residue of f of z at z equal to 5. Next one. If z equal to z naught is a simple pole of f of z. If z equal to z naught is a simple pole of f of z, then residue of f of z at z equal to z naught is limit z tends to z naught, z minus z naught into function of z. If z equal to z naught is simple pole of f of z, then residue of f of z at z equal to z naught is limit z tends to z naught, z minus z naught into f of z. If, for example, f of z is z plus 1 by z minus 2 into z minus 4. Here z equal to 2 comma 4 are simple poles. Now residue of f of z at z equal to 2 is limit z tends to 2, z minus 2 into z plus 1 by z minus 2 into z minus 4. Z minus 2 cancel. When z is tending to 2, 2 plus 1, 3 by 2 minus 4, minus 2. Minus 3 by 2. Residue of f of z at z equal to 4 is limit z tends to 4, z minus 4 into z plus 1 by z minus 2 into z minus 4. Z minus 4, z minus 4 you can cancel. When z is tending to 4, 4 plus 1 by 4 minus 2 is 2, 5 by 2. Residue of f of z at z equal to 4 is 5 by 2. Residue of f of z at z equal to 2 is minus 3 by 2. Next, if z equal to z naught is a simple pole of f of z, where f of z is in the form of phi of z by psi of z, phi of z naught is non-zero, but psi of z naught is 0, then residue of f of z, residue of f of z at z equal to z naught is given by limit z tends to z naught, phi of z by psi dash z, numerator by differentiation of denominator, that gives residue. For example, f of z is cot z cos z by sin z at z equal to 0. Cos 0 is 1, numerator. Cos 0 is 1, not equal to 0. But denominator sin 0 is 0. Denominator 0. Now, therefore, residue of cos z by sin z at z equal to 0 is limit z tends to 0, cos z by differentiation of sin z, cos z cancel, that is 1. The value of residue of f of z at z equal to 0 is 1. Next one, if z naught is a pole of order m, z naught is a pole of order m, then residue of f of z at z equal to z naught is limit z tends to z naught 1 by m minus 1 factorial into d power m minus 1 by dz power m minus 1 of z minus z naught whole power m into f of z, z minus z naught whole power m into f of z. For example, f of z is e power 2z by z minus 1 whole cube z equal to 1 is a pole of order 3, residue of f of z at z equal to 1 is limit z tends to 1 by 2 factorial into t square by dz square of z minus 1 whole cube into e power 2z by z minus 1 whole cube. Z minus 1 whole cube, z minus 1 whole cube you cancel. Continuation. Limit z tends to 1 by 2 d square by dz square of e power 2z. Limit z tends to 1 by 2 into 2 times differentiation of e power 2z, 4 into e power 2z, that is 4 by 2 into e square, 2e square, residue is 2e square. Now the residue of f of z at the simple pole 7 minus 3z by z square minus zr. Observe, f of z is seven minus 3z by z square minus z of z minus 1. Observe, residue of f of z at z equal to 0 is limit z tends to 0, z minus 0 into 7 minus 3z by z into z minus 1. Z cancel. 7 minus 0 by 0 minus 1 minus 7. Residue of f of z at z equal to 1. Limit z tends to 1. Z minus 1 into 7 minus 3z by z into z minus 1. Z minus 1, z minus 1 cancel. 7 minus 3z is 4 by 1. Final answer is 4. Minus 7 comma 4. Next, the singularity of the function z minus 1 by z square at z equal to 0 is, so z minus 1 by z square at z equal to 0 is what type of singular point? We have to find out whether it is removable singular or essential singular. We have to identify. Understood? Now z minus 1 by z square z by z square is 1 by z minus 1 by z square. See, both are negative powers of z. There are finite number of terms in the principal part of f of z. Therefore, z equal to 0 is a pole. So here it is a pole. The singularity of the function at z equal to 0 is pole. The residue of f of z 8 by z by 8 minus z cube at z equal to 2 is z by 8 minus z cube at z equal to 2 is at z equal to 2, numerator is non-zero but denominator is 0. That's why residue of z by 8 minus z cube at z equal to 2 is given by limit z tends to 2. Numerator you write as it is. Differentiate denominator with respect to z. Minus 3z square. Limit z tends to 2. Z by minus 3z square is 1 by minus 3z. 1 by minus 3 into 2. Minus 1 by 6. The value of residue is minus 1 by 6. Next problem. The residue of f of z at z equal to 1 is z equal to 1 is a pole of order 2. That's why limit z tends to 1, 1 by 1 factorial d by dz of z minus 1 whole square into z square by z minus 1 whole square into z plus 2. Z minus 1 whole square, z minus 1 whole square you can cancel. Now limit z tends to 1, d by dz of z square by z plus 2. Limit z tends to 1, z plus 2 into differentiation of z square is 2z minus z square into differentiation of z plus 2 is 1 by z plus 2 whole square. That is 1 plus 2 3, 3 to just 6 minus 1 by 1 plus 2 whole square is 3 square 9, 5 by 9. The value of residue at z equal to 1 is 9, 5 by 9. Next one, the Taylor series expansion of f of z equal to log 1 plus z by 1 minus z. Now expansion of log 1 plus z is z minus z square by 2 plus z cube by 3 minus z power 4 by 4 plus and so on. Log 1 minus z is minus z minus z square by 2 minus z cube by 3 minus z power 4 by 4 and so on. first term, whenever you are subtracting plus 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 plus, so minus plus cancel, minus plus cancel, log 1 plus z minus log 1 minus z equal to 2z plus 2 into z cube by 3 plus and so on, log 1 plus z by 1 minus z is 2 times of z plus z cube by 3 plus and so on. That is nothing but 2 into z power 2n plus 1 by 2n plus 1. Next problem. Find the residue of 1 minus e power 3z by z power 4. 1 minus e power 3z by z power 4. One minus e power 3z by z power 4, that is 1 minus 1 plus 3z plus 9z square by 2, 3z whole cube 27z cube by 6 and so on by z power 4. 1 minus 1 minus 2z minus 9z square by 2 minus 27 z cube by 6 and so on by z power 4. 1 minus 1 cancel, minus 2z by z power 4 is minus 2 by z cube minus 9 by 2z square minus 27 by 6z and so on. Now, residue of f of z at z equal to 0 is coefficient of 1 by z minus 27 by 6, that is minus 9 by 2 find the residue of f of z. Find the residue of f of z. Find the residue of f of z. Find residue of f of z. 1 minus cos z by z. That is 1 minus z square by 2 factorial z power 4 by 4 factorial and so on by z, that is 1 minus 1 plus z square by 2 factorial by z, z by 2 factorial minus z cube by 4 factorial plus and so on. Now, what is coefficient of 1 by z? Coefficient of 1 by z is 0. Therefore, residue is 0. Find the residue of f of z 1 plus e power z by sin z plus z cos z f of z is 1 plus e power z by sin z plus z cos z at z equal to 0. See, at z equal to 0, numerator is non-zero but denominator is 0. Now, residue of 1 plus e power z by sin z plus z cos z at z equal to 0 is limit z tends to 0. Write numerator as it is. Differentiate denominator. Cos z plus cos z into differentiation of z is 1 minus z sin z. When z is tending to 0, numerator is 1 plus 1 by 1 plus 1 minus 0. That is 2 by 2. That is 1. The value of residue is 1. The residue of sin root z by root z. So what is residue of sin root z by root z? If you write expansion, sin root z expansion, one sin root z expansion, root z minus root z whole square, root z whole cube, z root z by 3 factorial plus root z whole power 5, z square into root z by 5 factorial and so on by root z. Root z by root z 1, z root z by root z, z by 3 factorial, z square root z by 5 factorial is z square by 5 factorial and so on. So what is 1 by z? There is no 1 by z. That's why residue is 0. Residue is 0. Next, the residue of f of z equal to z into e power z by z plus 1 whole cube, z into e power z by z plus 1 whole cube, whole of order 3. We have to calculate residue at z equal to minus 1. Residue of f of z at z equal to minus 1 is limit z tends to minus 1, 1 by 2 factorial into d square by dz square of z plus 1 whole cube into z into e power z by z plus 1 whole cube, z plus 1 whole cube, z plus 1 whole cube cancel, limit z tends to minus 1, 1 by 2. When you differentiate z into e power z 2 times, you will get z into e power z plus e power z का differentiation. Now continuation. limit z tends to minus 1, 1 by 2 into differentiation of z into e power z is z into e power z plus e power z plus e power z. Now when z is tending to minus 1, minus e power minus 1 plus e power minus 1 plus e power minus 1, minus e power minus 1 plus e power minus 1 cancel. That is 1 by 2 into e inverse, 1 by 2e. Residue of f of z at z equal to minus 1 is 1 by 2e. Next, find the residue of f of z at z equal to 0 is, find the residue of f of z at z equal to 0 is 1 plus 2z by z square plus z cube at z equal to 0. Now residue of f of z at z equal to 0, 1 plus 2z by z square of 1 plus z. So z equal to 0 is pole of order 2 na. That's why limit z tends to 0, 1 by 1 factorial d by dz of z square into 1 plus 2z by z square of 1 plus z. Z square cancel. Now limit z tends to 0, d by dz of 1 plus 2z by 1 plus z. Continuation. Limit z tends to 0, d by dz of 1 plus 2z by 1 plus z. Denominator is 1 plus z whole square. Numerator 1 plus z into differentiation of 1 plus 2z is 2 minus 1 plus 2z into differentiation of z is 1. Limit z tends to 0, 2 plus 2z minus 1 minus 2z by 1 plus z whole square. 2z minus 2z cancel, 2 minus 1 is 1 by 1 plus 0 whole square is 1. Finally residue is 1. The residue of e power z by z power 2011, z power 2011, e power z by z power 2011, one plus z square by 2 factorial plus and so on by z power 2011. See here, coefficient of 1 by z is called residue. So you will get 1 by z when z power 2010 by 2010 factorial by z power 2011 comes, you will get 1 by z. Therefore residue of f of z at z equal to 0 is coefficient of 1 by z. Coefficient of 1 by z is 1 by 2010 factorial. 1 by 2010 factorial is the answer. Next problem. The residue of f of z equal to z square sine 1 by z. Sine 1 by z is 1 by z minus 1 by z cube by 3 factorial plus 1 by z power 5 by 5 factorial and so on. Z square into 1 by z is z. Z square into 1 by z cube is 1 by 3 factorial into z. Z square into 1 by z power 5 is and so on. Now, what is coefficient of 1 by z? Minus 1 by 3 factorial. Coefficient of 1 by z, that is minus 1 by 3 factorial, minus 1 by 6. The value of residue is minus 1 by 6. Now, find residue of f of z at z equal to 1. Five z minus 2 by z into z minus 1 at z equal to 1. Limit z tends to 1, z minus 1 into 5z minus 2 by z into z minus 1. Z minus 1 cancel. Limit z tends to 1. 5 minus 2 is 3 by 1, that is 3. That is 3. So answer is 3. The function f of z is e power z plus e power minus z. How many zeros? Or finite number of zeros, or no zeros, or only real zeros, or infinitely many zeros? See here, f of z is e power z plus e power minus z means 1 by e power z. That is nothing but e power 2z plus 1 by e power z. So e power 2z equal to minus 1. E power 2z plus 1 equal to 0, e power 2z equal to minus 1. E power I pi. So 2z e power I pi plus 2n pi. 2z equal to 2n plus 1 into I pi. Now z equal to 2n plus 1, 2n plus 1, not I pi, 2n plus I into pi. 1 minute. Different values of n you are getting. different solutions. Therefore, how many number of roots? Infinitely many zeros is the correct answer.